dcfldd is a feature-enhanced version of the DD copying utility and is based on the DD source code found in the GNU Core Utils package. The name dcfldd is short for Department of Defense Computer Forensic Lab DD. This name was given by the author of dcfldd, who was working for the DCFL when dcfldd was created. dcfldd operates under the same idea as DD in that it copies data from one location to another and performs data conversions and reformatting as specified. dcfldd expands on the capabilities of DD by the ability to perform hashing as data is being acquired, saving acquired images into multiple files, splitting acquired images into multiple files, wiping and verifying media, and displaying an in-process progress indicator. Before deciding to seriously use dcfldd, you should realize that the current version of dcfldd is quite old and unimproved. Also, dcfldd only produces raw image files and it does not handle media errors very well. Before we go on, I must warn you that this demo is destructive to the contents of digital storage media. If you accidentally copy an image to the incorrect target device, you can unintentionally and likely irreparably destroy data that you wish to preserve. For this reason alone, I always advise using a hardware write blocker on your source media as a failsafe, even in non-forensic situations, in case you were to make this mistake. A single protocol that emphasizes maximum safety for handling all disk imaging scenarios is best. In this demo, we will see how to use dcfldd to acquire an image from a device to one or more files, burn an image to one or more media devices, perform a device-to-device copy, split the output of dcfldd into multiple files, and how to hash and verify the raw images produced by dcfldd. I will assume that you have already watched my demo of the DD disk copying tool. dcfldd uses the same command line syntax that DD does, so this demo should look familiar to you. If you are specifically looking for a demo of the media wiping capability of dcfldd, I cover that in the Digital Media Wiping Tools clip in this module. First, let's run through the basic image acquisition and burning operations using dcfldd. To copy the entire contents of a device to a raw image file, the parameters are identical to DD. Just like with DD, the IF option specifies the input file or device, and the OF specifies the output file or device. dcfldd allows specifying multiple OF options for saving the same acquired image from multiple files or devices. You can also see one of the improvements upon DD is the in-process progress indicator. Burning an image file to a block device is also performed using the same options as DD. And yes, you can burn to multiple output devices simultaneously by specifying multiple OF parameters. Once again, be very careful when performing any operations that write to files or devices. If you want a single acquired image to be split into multiple smaller files, with DD you needed to use the Linux split command. With dcfldd you only need to specify the threshold size of each part in bytes and the format of the file extension used for each image file part. The split threshold can use the letters M or G to indicate megabytes or gigabytes. The split format can be numerical, left padded with zeros, and incremented from 001. Or alphabetic and incremented starting from AA. Note that the split operation is only applied to the output name listed after the split and split format options. Any output files appearing before the split options will not be split. If you are having problems with the dcfldd split operation, you can use the Linux split command instead. The first command line splits output files using a 3-digit extension, and the second command line splits files using 2-letter extensions. You can join the multiple parts into a single file by streaming them as input to dcfldd. dcfldd can produce hash values as an image is being acquired. Hashing on discrete-sized blocks of acquired image data can also be performed. The hash option specifies the hashing algorithms to use separated by commas. The default hash is MD5. And there are a lot of choices. The hash window option allows hashing the input as separate blocks of the size specified in bytes. If the hash window option is not present, the entire input is hashed to a single hash value. The hash log option specifies the file to write the hashing output to. This is handy if you need to include the hash values in your documentation. The presence of any hashing option on the ddfl command line causes hashing to be performed. Verification that the output of dcfldd matches the input is provided by the vf and verify log options. VF specifies the file to be checked against the input, and verify log specifies where to write the verification results report, which is empty if there was a complete match. Verification must be performed as a separate operation after image acquisition is performed and will error if the OF parameter is also specified. There is also no progress indicator displayed during the verification process. In this demo, we saw how to acquire and burn images using dcfldd, how to make multiple copies of a media device, how to have dcfldd split acquired image data into multiple physical files, how to join those multiple files into a single image file, how to hash entire images including block hashing, and verifying that the input and output of dcfldd is identical.